So we want to solve for theta here. The equation 2 times the cosine of theta equals the square root of 3, where theta is some angle between 0 and 2 pi. So I'm going to do this a couple of different ways. First, I'm going to do it geometrically, and then I'm going to look at it function-wise. So to solve an equation like this, if this was 2x equals the square root of 3, I would divide by 2. So there's no reason I shouldn't do that first. So get rid of the multiplication by dividing by 2. So now we get the cosine of theta equals the square root of 3 over 2. And I say, whoa, I remember that. Square root of 3 over 2 is one of those special x values on the unit circle for a special angle. So I'm going to whip out the unit circle here to think about this. Remind myself, and you might already off the top of your head know what that angle is. So on the unit circle, cosine is an x value. So this says find x equals the square root of 3 over 2. On the unit circle, this would be x equals 1, x equals -1. Square root of 3 over 2 is about over here. So that's the x value I want. That x value goes to either that point up there, or it goes to that point down there. So that means I have two possible answers. One is this angle right there. That angle is within 0 to 2 pi. But I also could keep going around till I get over to this radius. And so there's another solution right there. All right, so let's say the red one, we'll call that theta 1. And the blue angle we'll call theta 2. So I see two solutions on the unit circle. What are they? Well, thinking back again to my memorization of the special angles, that angle right there ought to be pi over 6. So there's one answer, and I can check that on a calculator in a moment. Now the other one, well, this would be negative pi over 6 in that direction. So from a complete revolution of 2 pi, if I just back off pi over 6, that would be one way to talk about this blue angle. So 2 pi minus pi over 6. Or I could count by pi over 6 to get there. So I'm going to try that too. So if I count by pi over 6, this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6 takes me to pi. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So this ought to be 11. Oops, it's pi. 11 pi over 6. Should be that angle. So my claim is my original equation can be solved with two different angles from 0 to 2 pi. Solution number 1, 2 times the cosine of pi over 6 should equal the square root of 3. Solution number 2, 2 times the cosine of 11 pi over 6. Oops, 11 pi over 6 should also give me the square root of 3. Let's check those on the calculator, see if they work. So 2 times the cosine of pi over 6 should be equal to the square root of 3. And we saw the square root of 3 earlier. It's about 1.7-ish. Double check. Square root of 3. There's that same number. I also claim that 2 times the cosine, or you could just type 2 cosine of 11 pi over 6 should give me that same number, and it does. So knowledge of the unit circle allows me to solve these problems. How else could I check it? Well, I could think about it as functions. What do I mean by that? What I could do here, alternatively, to check is I could graph the left side of the equation, we'll call that y1, equals 2 cosine of x. And then I could graph the right side of the equation, we'll call that y2, square root of 3, and just look at the graphs and see where they intersect. Now, I'm not going to get exact answers there, I'm just going to get approximates. And so again, I thought one of the answers was pi over 6, which is about 0.5-ish, and the other was 11 pi over 6, which is about almost 6. So now if I graph y equals twice the cosine of x, and I compare that to the graph of y equals the square root of 3, I should see a whole bunch of solutions. I'm looking for solutions from 0 to 2 pi, right, which is up to that peak right there. So that means I want this solution here, nicely gives it to me, and I want that solution there. So if I have a special angle, notice Desmos knows special angles too. So it's confirming the solutions I found earlier. Now, why didn't we just do this first? Well, the reason we didn't do that first is because I need you to know how to do this kind of analysis right here, this geometric analysis. So I do expect to see some written work like this from you. So please practice that.